Alright guys, today I'm going to go over 1.7 homework part 1. It starts on page 54. It's 1, 2 to 22 even. Just FYI, I am using a new program since the last program has not been letting me download the videos and then upload them to YouTube. So if there's any issues on this, I apologize in advance. So 1.7 homework part 1. The biggest scene that we're going to start with is this is a picture of the board. And with part 1, we're going to focus on this idea of identifying a perfect square trinomial. So the first couple questions are going to deal with identifying a perfect square trinomial. Remember, it's got to have 3 terms on one side. Those 3 terms, it has to begin and end with a perfect square. Here's your list of perfect squares. And then we have to be able to factor into matching parentheses. That's important because our goal is to make it one set of parentheses squared, because then we're going to use PEMDAS backwards. All right. Part 2 of this is going to be using this idea of creating a perfect square trinomial. We're not going to have a perfect square trinomial, so we're going to have to make a new C that's going to make it work. As we're going to use C equals B over 2 squared. Okay. Number 1, what is the difference between a binomial and a trinomial? That should be pretty easy. A binomial has 2 terms. A trinomial has 3 terms. That's it. That's it for number 1. 2, describe completing the square for an expression in the form x squared plus bx. Well, if you go back to your notes under step 2 on completing the square, it's when we're going to add c, remember, which c is equal to b over 2 squared, to both sides. Most common mistake, like I said, most people mess that up, so they forget to add it to both sides, to create a perfect square trinomial. That's it for 2. 4. Now the left side already is a perfect square trinomial because it has 3 terms. The first one is perfect. The last one is perfect. This 64 has nothing to do with that. Alright, so I'm not even looking at the 64. I only care about the left side. Now, the square roots add up to the middle, so I get to write this as x plus 5, x plus 5. What helps us out here is that these are the same thing, so I get to change that into x plus 5 squared equals 64. Now I get to use PEMDAS backwards. Remember, I'm allowed to use PEMDAS backwards at this point because there's 1 variable. Cannot use PEMDAS backwards because there's 2. Okay? So, I'm going to square root both sides. I end up with x plus 5 equals plus or minus. The square root of 64 is 8. Remember, if 64 is perfect, the radical disappears completely. Now I'm going to get rid of the plus 5 by subtraction, so I get x equals negative 5 plus or minus 8. Since there's no radical remaining, you do have to split this up. And you have to do negative 5 plus 8, and you have to do x equals negative 5 minus 8. So you're going to get two different answers with no radicals. X equals 3, and x equals negative 13. So those are your 2 answers for 4. 6. Once again, it's a perfect square trinomial. The left side has 3 terms. 1, 2, 3. Begins with a perfect square. M squared is perfect. 1 is perfect, and it works out because it factors into m minus 1. M minus 1. Since those match, I get to write it as m minus 1 squared equals 144. And now I get to use PEMDAS backwards. So remember, the subtraction's inside the parentheses. There's no addition, no division, no multiplication. I get rid of the exponent, and that's why I square root both sides. I end up with m minus 1 equals plus or minus, because whenever you square root both sides, plus or minus shows up. 12, because 144 is perfect. Now I add 1 to both sides. So I get 1 plus 12, 1 minus 12. And those are my 2 answers. And that's it for 6. 8, another one that's a perfect square trinomial. It's got 3 terms. X squared is x and x. 81 is 9 and 9. It works out for the middle, so I get to write it as x minus 9, x minus 9. Since those match, I get to write it as x minus 9 squared equals 5. Once again, now that I'm down to one variable, I get to do PEMDAS backwards. I have to square root both sides. I end up with x minus 9 equals plus or minus radical 5. It just stays radical 5 since 5 is not perfect. So now I add 5. Now I'm going to add 9 to both sides. I get x equals 9 plus or minus radical 5. And that's it for 8. 10. 10 is a little bit harder. So, I break down 4u squared into 4u and 1u, and I break down 1 into 1, 1. So I end up with 4u plus 1, 1u plus 1. Now I'm going to get to write it as u plus 1 squared equals 75. And now I get to use PEMDAS backwards. Now I square root both sides so plus or minus shows up. 75 is not perfect, but 25 as it goes into 3 times. So it's 5 radical 3. And then I subtract the 1. And that's your answer. You don't have to write that one twice because the plus or minus means twice, and because of the radical involved, we're not going to write it twice. 12. Another perfect square trinomial. Left side's 3 terms. That should be a plus 4 here. How do I get 4? Well, 2 and 2. I want them both to be negative. And now I'm just going to use PEMDAS backwards. I square root both sides. I get x minus 2 equals plus or minus. Remember, negative 1 inside the radical just turns into I. So I get x equals 2 plus or minus I. So that's going to be split into 2 ways. X equals 2 plus I and x equals 2 minus I. Which is A on your choices. Now 14. 14, you have to make a new C. So I don't know what C is. So to find it, I say C equals B over 2 squared. Well, this time B is 12. So it's 12 over 2 squared, which is 6 squared, which is 36. So I plug this back in. This is like the proof. I want you to prove that you did it right. So I plug 36 in. I'm going to see if it factors out. X and X. 6 and 6. The squares up to 12. So this is X plus 6. X plus 6. So it does factor into X plus 6 squared. So that's the proof. This is your answer. That's your C. Same thing here. C equals negative 30 all over 2 squared. Remember, it's inside parentheses, so even though it's negative 15 squared, it's still going to give me 225. That's my answer. Now the proof is when I plug it in, I'm going to see, does it work? It does. X minus 15. X minus 15. So that's the proof. So this is the proof. This is the answer. Alright? And that's it for 14 and 16. 18 and 20. Very similar. So there's my B. I'm going to say C equals 50 over 2 squared, which is 25 squared, which is 625. Now remember, I'm going to plug this 625 in right there for C. And it does work. X and X, 25 and 25. So it becomes X plus 25 squared. Remember, the green is the proof. This is your answer. 20, same exact thing. Now the interesting part is that what I'm trying to get you guys to see is that, notice, whatever is inside the parentheses before you square it is what's inside the parentheses after it, at the end. So 20 is tough because it's a fraction, but just going to do this. C equals negative 13 over 2 squared. I'm just going to square the top and the bottom. I'm going to get 169 over 4. So when I rewrite this, I write as x squared minus 13x plus 169 over 4. Now I don't have to do any much work here. I just put minus 13 over 2 inside the parentheses because I know the factors are that. So that's it. 22. 22 is actually going to use the steps for completing the square. Step 1 is already done for you because they already have 1x squared plus bx on one side. So that's done. So that means I have to create a c. C equals 4 over 2 squared. Half of 4 is 2, so it's 2 squared, which is 4. So I'm going to add this to both sides. I'm going to put it there and there. So like add it there and there. So the left side becomes x plus 2 squared because that's a perfect square trinomial. The right side is 14. Now I get to square root both sides, and I'm just going to solve using PEMDAS backwards. So I square root. I end up with x plus 2 equals plus or minus square root of 14. I subtract 2 from both sides, so the best answer is x equals negative 2 plus or minus the square root of 14. And that's it for 22. And that's going to finish this assignment.